So I've given it a couple of minutes, we'll begin. So I just want to say welcome to Trilio's March webinar. As you can see, the topic of the talk today is the rise of OpenStack in the enterprise and the need for intelligent recovery. So I'm Kevin Jackson. I am the director of the solutions architect team here at Trilio. I have the very lucky job of managing a very experienced team of people that are spread around the globe. We, live and breathe OpenStack. We live and breathe the likes of Kubernetes. So you're in very good company today, and certainly as you continue your conversations with us here at Trilio. Myself, I have been at Trilio for the last 4 years. Prior to that, my world has been OpenStack. I have been in the OpenStack space since the A release, the original A release of OpenStack. And I've been very lucky, in my career of working with many organizations and working for the likes of cloud organizations like Rackspace before joining Trilio. So it's a little bit of, obviously it's a little bit of an in-joke to certainly all my colleagues in Trilio that this is obviously my favorite platform. Hopefully that will come across today. I do have a big soft spot for this cloud known as OpenStack. So the, my keyboard's playing up. So the agenda for today is, well, one of the challenges for today is I'm trying to keep this talk to something, an appropriate time scale. I've seen a couple of familiar faces on this webinar today. It's good to see you again. You're very familiar with the fact that I have a habit of talking far too much about OpenStack. But I have condensed a lot of knowledge into hopefully the next 40 minutes, maybe a little bit less. And this is the agenda that I came up with. I'm going to take you on a little history lesson of OpenStack. It's not, I'm not going to take you, too much of take too much of the talk through the history, but it is important to see where OpenStack has come from in the context of Trilio and the world of backup and recovery. So it's very important to see that evolution. Obviously, we talk around like, why do I need to do this thing called backup? But then we'll quickly see that it's far more than backup. And then, of course, I'll show you the good stuff. I'll take you through Trilio for OpenStack and show you some demonstrations. And then if there are any questions, fire them over into the chat if you can. Hopefully I'll be able to monitor this. If not, my team will be able to monitor those questions. If not, my email address will come up at the end of this webinar, and feel free to reach out to me. As I say, I've got a fantastic team behind me and within Trilio. If I can't answer your questions, we certainly will be somebody intelligent in the company that will be able to respond to you. So again, I'm going to start off with that history lesson. So it's the evolution of OpenStack. How do we get to OpenStack that we love today? I won't go too long on this, but of course, I had to start somewhere. And so in the early days, of course, in IT, things were a lot more simple. We had these things called servers and bare metal. I appreciate we have those things now, but in the early days, it was a case of if my application was running somewhere, you could walk into a data center and actually point at your running application. So they were the good old days. If something went wrong, there would be smoke coming out of a server. You would know the fact that your application is down. So like clear, we've had clear improvements in monitoring since then. However, we've now iterated into the world, or things moved on from bare metal into virtualization. Virtualization really came about arguably because the servers got more powerful. There was a need to actually make efficient use of servers. And so they found out how to run multiple applications or multiple variants of operating systems with applications in on to single servers. So suddenly, instead of having to buy another 3 servers, you just spun up another 2 VMs, for example. So you can easily scale and manage your environment in such a way. Now, of course, that's pretty great, but you can clearly see that the next step of that, considering that virtualization really is it made the physical elements of bare metal and turn them into software elements. This is where cloud really, took off. And it's the reason why over the last, 16 years, we only ever really talk of cloud. Everything is cloud, of course, but quite rightly so. Cloud comes with APIs. Cloud comes with this notion of everything is software. Cloud comes with this notion of I can orchestrate things which previously was somebody wheeling stuff into a data center, having conversations with somebody to deploy applications. I can now achieve this with a single command from my keyboard. So I like to see this a slightly different way, though. So obviously that's the evolution of how we get to the world of cloud. But really, what we were really talking about there is the evolution of the ownership of those particular platforms. So certainly as we go through, the ownership has changed. So certainly in the bare metal world, as if anybody's as old as me, knows that these physical machines needed to be water and fed, they connected to networks, you would have different siloed teams that managed certain aspects of those servers. And when we go to the virtualization world, nothing really changed. Okay, there was a virtual, admin, there was certification on, the big known, hypervisors out there, but ultimately it was still a world of virtualization, plus all the traditional siloed elements of, server admin, storage admin, network admin, the different teams that you would walk around in an IT department. But cloud has a different model. It's obviously a shared ownership model. Cloud is a world where the administrators own below the cloud. They own the cloud itself. They deploy the OpenStack that the users come along and are able to consume. And it's this idea of these users that are able to consume those services, which lead itself to a different level of ownership. In other words, a user, an administrator knows that this machine is part of a cloud. They deployed this server as part of the OpenStack cloud, but there is little visibility into what the user has deployed into that cloud. And that is obviously by design. That's the whole idea of this. The idea here is you are separating responsibilities. The server admin didn't have to know how the banking system fundamentally worked, had to have an awareness of how it all glues together, but didn't have to, it's not the domain knowledge of the server admin or the network admin to understand this. So there's a clear delineation in ownership and understanding. So it's all about pushing the ownership up the stack to the user. So the user is able to orchestrate things, automate things. Let's say an application that ran on compute node number 1 on one day might have auto scaled, and now it runs on 3, 4, 5, different servers. Again, the admins under the hood only have to know that resources are being consumed. So again, there's a separation, but a dual ownership model. And of course, I point out the fact the server admin, and the network admin, they still exist, but a small evolution of the fact these days is there's a crossover in skills. So of course you now have this notion of a cloud admin. But that said, still the responsibility of what runs in that cloud is the domain of the user. I'm consuming some services, so therefore I'm going to deploy my services my way. So you've come here because you know Trilio, and you come here the fact that there's a topic around backup and recovery. So why are we having the conversations around backup and recovery when you use OpenStack? Obviously, in the very early days, and again, I'm not going to bore you again with more history lesson, but of course, in the early days, it was a notion that I deploy applications and I don't have to think about much. They're ephemeral. If I lost a web server, I wouldn't care too much. And to be fair, a lot of that is still true today. But it's pretty obvious, given the fact that we're now into year 13 of OpenStack, that is clearly not the case. Where certainly we have conversations of organizations running a variety of important workloads on large database clusters, telcos providing important highly available services across their stack. You can clearly see that there was a change in mentality of how and where OpenStack is being used today. Why should we care about these backups? Well, I'm going to just change the question slightly. If we think about the traditional way of looking at backups, if you look at the world of the focus really is around infrastructure. It's around about the storage, around about those physical elements. And that's where, traditional tooling kind of grew up, right? So you've got the traditional incumbents that are well known in the ecosystem of how to back up various aspects of that traditional type of thinking and architecture. But along came cloud, and cloud has this different view of the world. It's more software defined. Everything is code. It's all about self-service, that delineation, that shared ownership model of the administrators look after one aspect, which is providing the service, and the users come along and then consume the service. So how does this affect you and your users' backups? If you think about the fact that the traditional server admin or even the cloud admin has little understanding, and in a lot of scenarios, certainly when we speak to service providers, has very or zero understanding of what workloads are running on the cloud, then when we have a question like, how does it affect you and your users' backups? Well, clearly, how can a server admin know what to back up in a user's cloud, in a user's OpenStack project, when they have no idea how that project came to be? So again, going back to this evolution of ownership. Again, at the bottom layer, there is a need for backing up things. Okay, there's a need for recovery of the physical infrastructure, and there's various ways to do this. It's outside of the context of this conversation, but you want to kind of look around the world of GitOps and things about storing your configuration. And so the admin has a function in the lower levels of making sure the cloud is recoverable. But from an end user point of view, it's their data, it's their deployment, it's their applications. So quite rightly, shouldn't it be their backups as well? And the reason why I say this is backup needs have changed. There's obviously a drive for near zero recovery times. The world these days is impatient. Let's be really honest. And if you're providing a service to your company, or if you are providing a service to the public, and it's based on OpenStack or whatever cloud of your choice, then there's obviously a desire from the users to have their applications running all the time. The end users expect to be able to access the data. The users of a shopping system expect to be able to place that pair of jeans and put them into their shopping cart. It's well known that and a lot of studies that have shown that taking say the shopping cart mentality, and if your services are slow, or the page doesn't respond within seconds, crazy, but within seconds, shopping carts get abandoned. And that's insane. I grew up in a world, I'm old enough to remember when you ordered something online, or online was actually picking up the phone and speaking to somebody, it would take like 28 days for delivery, and that was the best case. So we have zero patience, but of course that's expected. That's all normal. We have the technology these days to get to near zero recovery times as well. So people want that, people demand that. Secure backups, of course, secure backups are just almost like table stakes these days. With the rise of malware and the rise of ransomware, everybody knows the fact that the easy easy recovery, that the get out of jail free card for those kind of scenarios is to be able to trust your backups to be able to recover your workloads. But you can only do that if you do trust them. And of course, security is high on the agenda. A lot of the traditional systems, hey, look, they can create secure backups as well. But you've got to start questioning how secure. And I'm like, this isn't fun. This is just a genuine conversation between me and friends. In the fact that, like, if you've got your system, it's your cloud, remember I said it's your deployment, your applications, and your data. Suddenly you're handing off your backups to a third party, a third party system that is beyond your control and visibility. That to me starts to question security. So people demand that they have these secure backups, and so therefore they need to trust that chain of trust. More than just data. So we're talking about the backup needs have changed, and backup needs have changed in the OpenStack and the cloud world. You can't get away any longer with thinking about, I just need to back up my data, or my storage team has provided some snapshots and it has some kind of service. It replicates the storage somewhere else and everybody's happy. We can't do that anymore. Storage is only one part of the puzzle in cloud. And I'll go on to that shortly, and I'll show you, what I really mean there. But yes, the data on your virtual machines, the things that are writing, obviously, unequivocally, very important. But it's not the most, it's the sum of all parts when it comes to backup. You need more than just a storage to actually have an effective recovery process. So you can't rely on snapshots. I know a lot of people start there. OpenStack kind of leads you down that particular path. Out of the box experience, you can go and right click and actually do things and say, select some storage and go down in the options, say, create a snapshot. There you go. Anything goes wrong, I can recover from my snapshots. But it doesn't allow you to recover from a failed Cinder, storage system. It doesn't allow you to recover from a complete cloud catastrophe. Of course, we're talking about these backup needs have changed. Of course, multi-tenancy, and self-service. This is a world where people are all consuming services. Everything is driven through a world of self-driven deployments. So, of course, the backup service has to cater for this. So again, you can't have a generic backup storage system that caters for a multi-cloud type of environment or a multi-tenancy environment. And talking about multi-cloud as well, in a similar kind of context, if you've got a system which has been great, for decades, you're running on-prem, because that's where our world began. It's all been in data centers, and you've got this incumbent system and it works fine. When you start to look at business strategies that stretch beyond your existing data centers, those backup tooling start to become more of an overhead. So we have to look at how an effective backup and recovery system works in a scenario of multi-cloud and hybrid cloud scenarios. So if we look at the kind of like, they're very easy for me to write this traditional way. Obviously when somebody comes along and in the old world, when somebody goes to make a backup, of course, some kind of backup service kicks into life. It could be on a schedule. It could be based on whatever the policy is that the company has dictated. And at some point, that storage is protected, or that environment is protected, whatever it is. And then when a recovery event occurs, obviously there's whichever way you want to, if you want me to go deep on foot, I can say it takes, hours to do a recovery. It could be just down to minutes. You can pick up a phone and speak to somebody and say, hey, look, I really need my data back. But there's a lag in terms of whatever the lag time is, there's a lag between being able to do that recovery. But however, in a traditional storage sense, that recovery is then quite limited. You've got your data recovered. But what does that really, really look like in an OpenStack context? Given the fact that we are talking 100% OpenStack here, you've got storage recovered. Is that Is that storage recovered all the way to the fact that the VM can actually use that storage? Is it storage so that it's there available? So you then have to go and tell Cinder and Nova to say, hey, look, now this is where your data is. You have to use this volume instead of that last one you used. So there's extra steps involved. But the new way shouldn't have to be like that. This journey into OpenStack, which is about self-service, which is about being able to do things on your own terms, allows you to say, okay, I can make a backup when I need to. And that could be on a policy basis, driven by and controlled by the company, or it could be on an ad hoc basis because a user is doing a point-in-time capture of their environment. And then using familiar tooling to them, because it's their workflow, it's their environment, they can then restore their application as it was, as they expect, without any further extra steps. Bringing up that same view of the world, the traditional view. But in this case, what about the world where people are using pipelines to do their development and doing their testing? In a world of CI/CD type of environment, where events trigger services to do stuff. And so in this case, calling a service to back up an environment because some destructive change is about to occur or some destructive testing is about to occur. The testing occurs, it has failed, it's red on the board. And so automatically you can recover that environment and essentially reset again. These are the demands that we have in cloud today. And so I think it's very easy to realize now that it has never been really about the backup. It's always been really about the effectiveness of your recovery process. It's all about the effectiveness of your how the restores occur. If you think about it, the backup is only one small piece. A backup you can create a backup. You can create your own backup process using cron. You've got a tarball of your var, lib, nova instances. There you go. You've got your backup of your VMs that are running on your compute nodes. What does a recovery look like? Okay, well, I can then untar those VMs, but OpenStack will have no idea about what those VMs are that you've now just recovered. So it is always, 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 always about the recovery. That's what we have to think about. It's never about the backup. So if we think about going back to this idea of why we have an OpenStack, well, the evolution of OpenStack and the reason why we evolved into this cloud is it's always about productivity. It's always been about the productivity. And if we think about what cloud brings, it's about ownership. And then that ownership drives that productivity. And that productivity is two layers. We discussed that it's a shared model. It's productivity for the end users, and it's productivity for the cloud administrators. Those cloud administrators, it doesn't have to be the domain knowledge admin of the financial application, the network, the NFV environment they have running in that environment. The idea of the cloud admin is they're the ninjas that know how to operate OpenStack itself. So it's always been about effectiveness, it's all about efficiency, and it's always been about productivity. And so by definition, we've talked the fact that it's never about the backup, it's always about the recovery. So therefore the recovery is about the productivity. If you are treating, or if you're going into conversation and just talking about backups, that's an insurance. Okay, you've got this idea that my backups are an insurance policy. But we've just seen the fact that when it comes to actually using those backups, then they are an effective part of your productivity of how you would manage and use your OpenStack clouds. So the evolution of recovery also is about productivity. And that's what we're trying to give you. We're trying to give you an effective enhancement to OpenStack that will drive and continue that drive to productivity in your IT departments for you as administrators and for your end users. So again, you use OpenStack. Why should you care about the backups? Well, let's take a look at OpenStack. That's what we're here today. Well, you can hear me talking all day long about OpenStack, and trust me, I can. But let's have a look at OpenStack. So this is a relatively benign kind of environment. It's a small environment. I have a few virtual machines. I've got some networking. It's important to me. This environment is important to me. But each of these objects has a catalog of extra information associated with each item. And so again, if you think of the storage-centric view of the world, then you can't just concentrate on one single aspect to do a recovery in OpenStack. And so if we drill down into detail of say, like just a single VM, this is just one single virtual machine that's being presented there. Again, for everybody who's familiar with OpenStack, this will look very, very familiar to them, of course. This is just the information view from through Horizon of an OpenStack instance. So it's a virtual machine. It has a name. It's got some UUID associated with it. It's got some flavors. It's got some networking information. It's got a whole load of stuff. But the traditional kind of like storage-centric mentality, even if you've got an agent-based solution, it's almost like, look, I'm only interested in the data that you're producing on this virtual machine. So the recovery in that case is a number of steps. So say, for example, you're doing just file and folder recovery in OpenStack. You would need the virtual machine to be recovered before you even do the recovery of the data itself. If you are taking a storage-centric view, so you go into your storage team, they're using, I'm not going to name vendors, but there could be whatever vendor in the back end, and they're going, hey, yeah, I can do a snapshot of this storage system. That's fine. Again, what does a recovery look like? If this environment goes down, you have to recover the environment. What are those extra steps that you have to take care of? The Trilio way takes care of all this. It essentially understands all this extra metadata, all this extra detail, plus any and all of your data associated with your virtual machines. And yes, we capture network detail, we capture the flavors, we capture all this. So I introduced to you, if you're not familiar, I'm going to introduce you to this wonderful product, this service for OpenStack called Trilio for OpenStack. It's the intelligent recovery service for OpenStack workloads. So this is a very high level view. And for those who are familiar, and if you have had a talk by myself or any of my solution architects, this obviously screen will look very familiar to you. And I start off here because I think it's really, really useful to explain with no uncertainty what Trilio is. So everybody in this call is probably familiar. I'm going to take a stab. Everybody's familiar with the fact that OpenStack that you deploy is made up of a number of individual services. We just know that standard cloud that we have these days comes with a Nova, a Neutron, a Glance, a Cinder, or whatever these days. So they're the core services, and they're responsible for one job only, really. So Nova is responsible for the lifecycle management of the virtual machines. Keystone has two jobs, authorization and authentication. And networking is handled by Neutron. So it's very easy to understand OpenStack in that kind of context. And so therefore, Trilio is just another one of those OpenStack services. So yes, I'm sat here in a Trilio hoodie today. We are called Trilio. We don't have a name like Nova and Neutron and things of that nature. The service is Trilio. It's an OpenStack service. If you do an installation of Trilio and do an OpenStack catalog list or an OpenStack endpoint list, you will see that we are part of the OpenStack catalog. We have a command line client. Our reserved word is workloads. And so you can do an OpenStack workload list. You can view your workloads from the command line. So 100% native to the OpenStack experience. We're fully integrated into a Horizon. I'll show you this in a demonstration that I've got. Fully integrated into the actual deployment itself. So of course, when we talk of OpenStack itself is can deploy it in 1,000 ways. Trust me, going back to day zero, it felt like there were 1,000 ways to deploy OpenStack. For those who thought that you had to buy a new switch and plug in some firmware and it simulated your environment to deploy OpenStack. Honestly, those days are long gone. Thankfully, these days we're kind of standardized on things like, over cloud deploy with Triplo and Director from Red Hat. We've got Kohler Ansible, OpenStack Ansible. We've got the world of Mirantis, OpenStack on Kubernetes. So there's standard ways of getting this deployed, but we are part of those deployment mechanisms. We're part of that process. If you're doing an Ansible-based deployment, you use Ansible, the same playbooks, just with the configuration of Trilio in there as well. We're fully agentless. I'll show you on the architecture slide next why that's the case. But essentially, with Trilio, you can install this, as day one or day two services. So if you've got an existing OpenStack cloud today, again, using like Kohler or Red Hat or whatever, you just add in the configuration for us where to pull down the containers, and we'll deploy into the environment as well. And so you get an extra service for your users to consume at that point. And then those users can, without making any modifications to their running environment, are able to make a backup of their workloads. Again, we're a service that doesn't need any change, so non-disruptive. Scalable, well, I'll show you on the next slide why that's the case. But we do scale in line with your OpenStack environment itself. Again, if you think about the concept here, there's nothing here that I'm showing you on this diagram. Bear in mind that, if you're familiar with OpenStack, it's part of the platform itself. This is not a third-party system sat at the side, which is designed to look at VMware, to look at Azure, to look at all the different environments. This is dedicated, and you get all the functionality and all the efficiency because it's only designed for OpenStack. And our backup formats are open formats. We store a lot of additional information through JSON, and we store the actual backups themselves through kubectl. So it's all open format. And that format allows us to have incremental capture of data forever. So you can have a full and then incremental captures forever. So the small changes since the last backup, minimizing the backup storage that we need. And we use the kubectl format in exactly the same principle, in the same way as how Nova would use it in a traditional sense if you're using the QEMU KVM type hypervisor. So going into the architecture itself. So again, I started off at the very beginning that I had, I've been here long in the tooth in terms of, OpenStack itself. I've been an OpenStack architect. I've been an engineer. I've done the deployments. I've got the gray hair to show. I've got the battle scars. So I appreciate I have the easier job of distilling OpenStack to a PowerPoint slide. But ultimately, OpenStack itself is made up of a control plane. And that is effectively the front door. That is the view, the conceptual view that a user has of your cloud environment. They have no idea of number of compute nodes you have in your environment. They have no idea what vendor of hardware your networking stack is. It's all buried behind a lovely interface of Horizon and through the APIs. And that runs on your control plane. And then, of course, you've got your compute layer, which is obviously your scale-out compute. You might have a group of computes, which are generic HP servers with Intel CPUs. And then you might have another group of compute nodes in a different part of the data center with GPUs in as well. So again, this complexity can be hidden from the users and just essentially presented to the end user in effectively just as drop-downs. Then, of course, you have your scale-out block layer too. Something that could be any type of backend storage. It could be Ceph, it could be NetApps, it could be IBM's storage, whatever it is in the backend. Now, where Trilio comes in, we're, of course, designed to give you as administrators the ability for your users to be very productive and be able to self-serve the backups of their workloads. And the workloads are spread across each and every one of those compute nodes. And we can write out those backups. And I'll tell you I'll show you on the next slide how we do these backups, what we back up as part of these backups. But essentially, we can write all that data out completely external to the OpenStack cluster. So if I go back whilst that's your standard OpenStack architecture, this is the additional requirement that we need. And hopefully it makes sense. We're going to be making backups of your environment, your workloads, the VMs and the volumes that are running in your environment. And we want to be able to safely keep that away from the whole of OpenStack so that if anything went wrong in OpenStack, you can recover from just this storage. We deploy APIs. We're an OpenStack service. Obviously, we're going to deploy APIs. Now, technically, we've got a couple of APIs. One of them is the front-end facing API that a user would interact with. And just like the way that somebody asks for, OpenStack server list, it makes a call to the Nova API. Well, OpenStack workload list makes a call to the workload API. Workload, remember, was our keyword. That's the thing that we use to describe what we're backing up. Hence why it's called a workload. We integrate into Horizon as well. You'll see this in the demonstration in a couple of clicks time. Everything's very normal. So again, we're not a strange third party that doesn't know how to use OpenStack. We're not a third party that has to deploy proxy servers into the environment to try and, kind of make it look like, hey, I'm ticking the box for OpenStack. We're literally the OpenStack service that has been born, should have said, over the last 8 years. For those who like their history, and you can see that I like going back in time in terms of OpenStack, we started off as Project Rackspace. That doesn't exist. It literally got renamed. Well, the blueprints do exist, but the product was Rackspace, and then it came commercialist. That's just Trilio. So if you like your history, that's the relationship between Project Rackspace back in the day and Trilio, just the commercial same product that we have. I say same, obviously, is very enhanced and developed since then. And then we have the data mover service. Now, this data mover service is really the key part of the puzzle on how we can do things in a very scalable way, how we can do things in an agentless way. You can see very deliberately it's deployed onto each and every one of your compute nodes. So just like you would describe a deployment where Nova Compute is deployed to each and every compute node, makes sense because Nova Compute is controlling the virtual machines, but we have the data mover service, which is also deployed to each and every one of those compute nodes. And you can see how this scales out. So you can start to see or start to get hints of the efficiency, given the fact that this service is the one that actually does the moving of data, the copying of data that we're going to be backing up. And if you follow these white lines, certainly from the compute nodes themselves, you can see that the actual backups that we take are not related to Neutron. Very deliberately, this is efficiently designed. It's not an agent-based solution. If you have an agent-based solution doing file and folder recovery, backup recovery in your VMs, because they're just a VM, your backup traffic is flowing through Neutron networks. And if you're familiar with Neutron and you don't run distributed virtual routers, then your routers live on your controller nodes. Remember, that's your first impression of your cloud. That's where your Horizon runs. That's where the database runs. Typically, in a lot of environments, they might be spread out. But typically, routers would exist on the controller nodes. So therefore, you've got traffic which is both serving the virtual machine and also serving and pulling out backups, gigabytes of files. Now, for a lot of environments, that's probably not a big challenge, but for some, it's worth considering. But we can avoid all that complexity. That's not our world anyway. So however you've got yours set up, that's completely up to you. But with Trilio, our backups, the data, the actual data that we want to back up, along with the metadata information, flows literally out of the compute nodes themselves and out to the controller nodes. So that means that you can have this notion of sending gigabytes of data out of like dedicated network interfaces, or you might have a dedicated storage network or a dedicated backup VLAN. We essentially just need access to NFS or S3. It could be direct access, it could be routed. However it is, it's just simple for us. It's just access to NFS or S3, and we're able to make backups. So what do we back up? Well, we back up the project, the tenant workloads. I should point out I'm old school. I still call the projects called tenants. So, obviously, if you're using OpenStack in the last 5 years, you're used to Horizon calling your different environments that you can switch to called projects. I'm old school. I call them tenants. So tenant networking, so the project networking space, your 4 walls, that's what we're backing up, the workload that runs in there. When it comes to the virtual machines, of course, we understand the size, we understand where it ran in the data center. When it comes to networking, this is the most interesting thing, I think, personally. With networking, whilst OpenStack is a dynamic environment, your virtual machine lived on an IP address, and that IP address was needed for whatever interaction was for other services, maybe through a load balancer at the front end, but it was important, that IP address. So we capture that IP address, we capture MAC address information, we capture security group information, and then interestingly, we capture the networking information as well. So if you've got a virtual machine on a particular network, we capture the network name, the subnet details, the routing, the DNS information. With Trilio, it's all about the recovery. With the Trilio, we can actually recover all the workloads, and I'll show you that in a demonstration, which I'll get to quite shortly. We capture all that detail. Again, we capture a ton of information. With volumes, you're asking us to back up this virtual machine. This virtual machine has 3 volumes attached. We'll back up those three volumes as well. One of those volumes could have been on an SSD type. Another volume could have been on a Ceph type. We capture the types, we capture the metadata, we capture the availability zones of your storage. And then when it comes to glance, we have an efficient way of being able to take backups of ephemeral rooted instances. So whilst you mightn't think they're uber important, and guaranteed there'll be a requirement to recover those workloads. And so what we do is we're able to do a backup in such a way that the recovery, it's always about the recovery, doesn't depend on your glance image catalog. You capture that base image as part of the overlay process. And therefore, with a Trilio-based OpenStack recovery, you can always recover your workloads, regardless of what's in your glance image catalog. So let me take you into a demonstration of this. I'm going to show you a demonstration. It's pre-recorded. I'm not going to, it's not smoke and mirrors here. This is real time, apart from I just shortened a step, which is part of the recovery of the data from the storage. But every part of this is in real time apart from that. And it's going to show you where I've got this world where we're going to start it off, where everything all looks normal. I've logged in as a normal user. This is me. I've logged into this environment, and these are my instances. But if you look on the left-hand side, we have a backups tab. The backups tab, if you ever see that, that is Trilio. If you go into the workloads, you can see that I've got some pre-created workloads. Bear in mind that workloads are, what are we going to back up? What schedule basis am I going to back these things up? And in this case, I'm backing up prod 1 and prod 2, and I've got a number of snapshots. Now, to us, snapshots are actual backups that get written to that S3 or NFS target. Now, what I'm going to do here is I'm going to delete my prod 1 and prod 2 instances. They're running Ubuntu Jammy. They are on 10.75 and 10.234. They're a medium flavor size instance, and I've deleted them. So maybe that was a mistake, but that's okay. I can go into my backups. I can go into my workloads tab. I can go into my production workloads. Again, this is me. I've not picked up the phone. These are my backups. It's my responsibility. And I can do what's known as a one-click restore of these workloads. And we can only achieve a one-click restore because we back up so much information. And essentially what's happening here is we back up all that information because our recovery process, it's always about the recovery process. You'll hear me say that so many times. You can call me boring and tell me off, but it is all about the recovery process. And what we do with our recovery process is it's orchestration. We capture, basically, we've got the ingredients of prod 1 and prod 2. We knew it was Ubuntu Jammy. We knew it was an M1 medium. We knew it was in my case, it was the Nova availability zone. And you can see the fact that we can just bring these back to life by saying to Neutron, create this port with this IP address, create this VM with this name prod 2, attach this prod 2 instance to this port, which has 10.10.234 on, for example. So there he is. There's the recovery. Very, very simple. And that was a one-click restore of my instances. Again, always about the recovery. But we can take this a little step further. Given the concept that our intelligent recovery process is orchestration, you start to get into the world of like, well, how can I use this effectively? Bear in mind, I told you that this is an evolution of productivity. It's an evolution of ownership. And you can see here, we can effectively use Trilio to do complex tasks within OpenStack. So we can do things like move workloads between tenants. I'm going to show you that on a demonstration shortly. We can do things like back-end storage migration because we orchestrate. We understand that we've backed up a VM based on a Cinder volume type, but you're in control. You actually, it's not part of the one-click restore. We have a number of ways of being able to do recovery process because it's always about the recovery. Told you, always about the recovery. And you can choose during your recovery step saying, okay, this MySQL table, it's no longer going to live on SEC. It's going to live on my, my SSD-based storage. You get that control because of orchestration. You don't get that in a one-to-one mapping world of just say storage. We facilitate the scenario of upgrade migrations. So that's the parallel upgrade scenario. So if you've got OpenStack deployment number one, so you're running OpenStack Queens, and you need to move to the latest, maybe or one of the latest versions. It could be Yoga version of OpenStack, for example. So what you can do is run Trilio and install and do a backup of your workloads on your Queens-based environment, and then have those recovery on the Yoga environment. We can take that a step further. Your Queens environment might be based on O, and your Yoga environment might be based on Core Ansible. So we can do inter-distro migrations as well, because we do orchestration as our recovery. We don't capture details that ties our backups to the original cloud. We have the ability to say, okay, well, everything that's important to me in this backup all exists on this storage as JSON and QCOW2. And Trilio understands how to effectively use that JSON information to actually then facilitate a recovery. And that's just using the command line, or you could be using Ansible, or you could just be using the Horizon interface. And then finally, disaster recovery, a variation on migration. It's almost like migration, but under a lot of pressure. This is a scenario where you've got workloads that have gone down, but it's okay. You've got Trilio. You've got those backups that are safely stored on that NFS or S3 storage. The only thing we need to do a recovery is that storage, as well as Trilio installed, of course. And so pointing that second cluster to that storage, probably replicated storage, you can facilitate an import and then workload recovery. So let me show you this migration. This migration demo here, again, same cluster, it's a single cluster. I'm going to be moving one of the workloads. It's the file server workload. I'm going to be moving that to a different tenant. It simulates a lot of the migration scenarios because the principles are all the same. So I'm in the Kevin demo tenant. I'm going to just show you the Kevin restore tenant. There's nothing in here, essentially. So while it's all playing in the background, essentially in OpenStack, everything that you see in the four walls of your project or tenant is owned by that project or tenant. So a Cinder volume created in a tenant or project is owned only by that project. A Nova instance is only owned by that project. A backup from Trilio is only owned by that project. So what we do here is we reassign that workload to a different tenant. So in this case, I've reassigned that using, you have to drop to the command line to do this. Horizon does not facilitate multifunctional view of your tenant workspace. So drop into the command line to say, reassign the file server workload from Kevin demo to Kevin restore. That could be Kevin demo to Kevin restore on cloud number 2. And in here, I can now just do a normal recovery. But, well, I say a normal recovery. This is a special recovery. This is a selective restore recovery where again, I'm logged in as a normal user, not an admin. I'm not doing anything special at this point. I am going to do a network topology recovery as well as the VM-based recovery. So not only am I going to recover this virtual machine, but where it lives as well, the subnet details, the networking, and you can see that previous networking space that was blank. Okay, apart from the external network, obviously that's shared across your environment. Before I even had a chance to click on here, the network information was starting to be created. I've got multiple networks. I've got a router. I'll soon start to see other objects appear, like the file server that is being pulled back from recovery. And we can achieve this level of intelligence because we're reading the metadata associated with this backup from the storage, and we're facilitating a recovery through orchestration, giving you the ultimate flexibility in a complex environment such as OpenStack. So this is my file server that's come back to life with its multiple IP addresses. There's the external network. Obviously, we didn't need to touch that. But essentially, I've now recreated using very simple steps, something quite complex. Now, again, talking about productivity. This removes the complexity from you as administrators. This removes that unknown of being able to, how do I take a workload, which you know are just a string of UUIDs that are associated to other UUIDs in this world that you know as OpenStack, then we make this terribly simple. So we come back to, like, you use OpenStack, why should you care about the backups? Well, backups are clearly, necessary, but it is the recovery, which is arguably the most important aspect. It is about productivity. It is about being efficient. You are happy, your workload reduces, your users are happy. They are far more productive. So we provide this across multiple platforms, of course. So obviously we're in here to talk about OpenStack. We have this same concept through Kubernetes as well. So if you recognize your logo of your favorite platform on here, please reach out and ask for further information. If you are interested in seeing this in any more detail, please just reach out to us. You've got my email address on the screen here. If you can't remember my email address, kevin.jackson@trilio.io, visit trilio.io and then go and click on the links. They come to real people when we go through the process, and you will ultimately get through to honestly, I cannot big up my SA team enough and the experts that we have in Trilio. So you will get to real people to discuss your needs. So thank you very much for your time. There is a question, so I'm just gonna have a look here, see if there is a QA. Okay, so in terms of providing support, the Trilio, we have consultants. We are able to engage with you on a one-to-one basis. So if you're interested in finding out further details on how this would work in your environment, how we can take this further, we are ready to engage with you in a very consultative way, understand your problems, and take you through all the way to production and 24/7 support, and able to support you around the world. So yeah, thank you very much for your time today. I hope that was really useful, and look out for more webinars in the future. So thank you.